Hello, you are welcome to my study room. My name is Mr. Chu, and today I'll be taking you through lowest or least common multiple, its applications, as well as highest common factor or greatest common divisor, GCD, and its application as well. Let's take the very first one immediately. Least or lowest common multiple, which is also known as L.C.M. Let's take that one immediately. L.C.M, what is it? L.C.M is the lowest or the smallest number other than zero. That is the common multiple of any two or more given natural numbers. The smallest number other than zero, that is the common multiple of any two or more given natural numbers. And in the classroom, we make use of L.C.M most or more when we are adding or subtracting fractions. Also, when we are solving simultaneous equations using the elimination method, we make use of L.C.M. So my aim today is to give you simple, quick and reliable steps that we can use to find L.C.M without any struggle. So let's take the very first question. Find the L.C.M of 28, 36, and 45. All right. So to solve this, what most of us already know is finding the multiples of 28, finding the multiples of 36, and then finding the multiples of 45. Then after that, we state the common multiples. Then we choose the smallest or the least one among them. What I've realized as the challenge of students is that most of them, when they are listing the multiples, they forget one or two of them, and that affects their answers at times. But I believe with this method, there is no way you are going to forget any multiple because you just get the L.C.M straightforward without listing, which is time consuming and then more difficult to do as well because you must know your timetable well and so on and so forth. So what do? We just put these three numbers in a table. And then be dividing them by the prime numbers until each of them, until we have one as the result for all of them. Then we take the product of the various numbers we use to divide as the L.C.M. So let's go. The least prime number we have is 2, and 2 can divide at least one or more of these. So we go quickly. 2 go into 28 14 times, go into 36 18 times. It cannot go into 45, so we repeat the 45. Then again, I want to arrange them chronologically. So the 2 can still go. I'll repeat the 2. 2 go into 14 7 times, go into 18 9 times, and then cannot go into 45. So repeat the 45. Now 2 cannot go into any of the three results you get here. But then the next prime number is 3. And 3 can go into these 2. So we use a 3. 3 cannot go into 7. We repeat the 7. 3 cannot go, 3 will go into 9 3 times and go into 45 15 times. All right. 3 can still go, so repeat the 3. Cannot go into 7, repeat 7. Go into 3 once. Go into 15 5 times. 3 5 15. Good. 3 can no more go. So the next prime number is 5. 5 cannot go here. Cannot go here. 5 will go here 1. Then we take the last one, which is 7. 7 will go here 1. Here you cannot go, so repeat. Here we can repeat. And like I said, the final here should be 1 1 1 1 for all of them. And then now we are going to multiply all these numbers we used to divide, and that will give us our LCM. So our LCM becomes 2 times 2 times 3 times 3 again times 5 times 7, and this is going to give us 1260. 1260. So that means that 1260 is the smallest number 28, 36, and 45 can divide. Therefore, the LCM of 28, 36, and 45 is 1236. Quite easy, right? Quite easy. Let's take another example. We take the LCM of we are finding the LCM of 10, 15, and 20. 10, 15, and 20. So again, we write our 10, our 15, and then our 20. The least number which can divide them is 2. So 2 will go into 10 5 times. 2 will go into 15, cannot go into 15. So repeat the 15. 2 go into 20 10 times. 2 can still go into 10. So I'll repeat the 2. Then my 5 because 2 cannot go. I mean my 15 because 2 cannot go. And 2 can go into 10 5 times. Then 3 can go into 15, so it moves to 3. 5. Sorry. 3, 5, 15. Good. And then we repeat this 5 again. Then now, the next one is 5. 5 will go here 1, go here 1, and go here 1. So therefore, the LCM will be 2 times 2 times 3 times 5. And this will give us 3, 5, 15. 15 times 2, 30 to 60. So therefore, the LCM of 10, 15, and 20 is 60. Is 60. All right. We can solve more examples, but the the process is the same. So for the sake of time, let's move on quickly to applications of LCM. A lot of students are very excited about this. Whenever they are teaching a topic, they want to know what the applications are or how is it related to their real lives. So I have a few applications here. So one of the applications of L.C.M is the time two or more athletes running in a circular track at different times, say 10 minutes, 12 minutes, or 15 minutes, respectively, will meet. So let's say somebody is running in a smaller track. Let's say this is the size of the track, and it will take 10 minutes to go around it. Another person is moving in a bigger one, let's say like this, it take 12 minutes. And then another one, let's say a little more bigger, it take 15 minutes. It take 15 minutes. And then we want to know how many or how long it will take all of them to come and reach the starting point again if they are going around. So it means that it will, after 1 hour, because we just found the LCM, okay, it was not these three numbers. So it means that for us to find what time the three of them will reach the starting point again as they are going around at the same time, just like the way they started at the same time, we need to find the LCM of 10, 12, and then 15. I think that is still 60. So that means that after 1 hour, they will all come and pass the starting again, or they will reach the starting point again if they should be going around at the same speed they started with. So that is one of the applications. Then another application is the time three traffic lights become green at the same time if they turn green at different time interval. Let's say 48 seconds, 72 seconds, or 108 seconds. So again, three different traffic lights, they keep turning green at time intervals. First one, 48 seconds, second one, 72 seconds, and the other 108 seconds. They are just examples I'm using. You want to know at what time all the three of them will become green at the same time. LCM is the best method you can use to find that. Then maybe I can add the last one. When you go to my hometown in the Volta region, we have different towns having different market days with different intervals. Some of them after every 4 days, some of them after every 5 days, and then some have very fixed date for their market. You want to know when two or three markets will fall on the same day, then you have to use L.C.M. You have to find the L.C.M. of the number of days each of the towns have their market day. Then you can know how many days after they all fall on the same day, they will fall on another, they will all fall on the same day again. So those are three applications of L.C.M. Let's move on quickly to H.C.F, which is highest common factor. Highest common factor, H.C.F. It is also called greatest common divisor. So GCD, greatest common divisor. So what is this one? Again, just as the name suggests, highest common factor. It means that you are looking for a natural number, the highest natural number that can divide two or more natural numbers without a remainder. And again, what we most of us already know is we find the factors of each of the numbers we have been given. And then after that, we again list the common factors. After listing them, then we pick the highest among them as the greatest or the highest common factor. But just like the first one, the mistake most of my students keep making is that when they are listing the factors, they forget one or more of the factors, and that makes their work wrong at times. So by using this method, you are going to avoid that mistake. Let's take some two examples again. So let's say we are finding the highest common factor of 48. Example 1. Find the highest. "48, 72, and 108. Good. Here we are going to use, for the H.C.F, we are going to use the same method, the same table, but this time we don't want to repeat numbers that cannot divide. We are only using factors that can divide all of them, and that becomes our H.C.F. Let's go into details and see. We have our 48, 72, and then 108. So we are looking only for factors that can divide all three of them at the same time. When you are finding H.C.F, you just look for factors that can divide all of them at the same time. So when you reach where there is no factor that can divide all of them at the same time, you stop there. So 2 can divide all three numbers. Because of that, we bring our 2. So 2 goes here 24 times, goes here 36 times, and then goes here 54 times. The same 2 can still go here 12 times, go here 18 times, and then go here 27 times. Then 2 cannot go into 27, so we cannot use 2 again. We go to 3. 3 goes here 4 times, and then goes here 3, 6, 18, and then goes here 9 times. 3, 9, 27. So, looking at 4, 6, and 9, there's no common factor again, because 2 can divide this and this, but it cannot divide a 9. 3 can divide 6 and 9, but cannot divide a 4. And that is it. So that ends our division. Therefore, our H.C.F is 2 times 2 times 3, which will give us 12. So that is the greatest common factor of 48, 72, and 108. Let's take another one. We are finding the greatest question 2. We are finding the greatest common factor of 28, 42, and then 56. We have our 28, 42, 56. As usual, 2 can divide all of them, so we choose 2 here. 2 go here 14, goes here 21, and goes here 28. Then 2 cannot go into 21, so you cannot choose 2, but 3 can go into all 3. So 3 will go here. No, 3 cannot go into 14. So we choose 7. 5 cannot go, obviously. So 7. 7 will go here 2 times. 7 will go here 3 times. And 7 will go here 4 times. And then I think that's all. So therefore, our H.C.F is these 2. So 2 times 7, which will give us 14. So the highest common factor of 28, 42, and 56 is 14. All right. Let's quickly go to the applications. So how does H.C.F apply in our everyday life? So for example, an application of that is you have 3 or more classes or 2 or more classes, and you want to give a group assignment to your students. And you want to form groups from all the 3 or the 4 classes to have the same number of members in each group without anyone left. Then you just have to find the H.C.F of the enrollment for each class, or the number on row for each class. When you find the H.C.F for the three classes, or how many classes you are finding, you find the H.C.F of all those numbers. Then it means that you can form groups of that number from all the classes without anyone left. So you just pick the classes, the numbers for the classes, then you find the H.C.F. That means that each group should contain those number of members. Then another one will be, you have a piece of canvas. A piece of canvas you want to use to make doormats, and you want to make square. Let me be specific with that. You make square doormats from the canvas, but you don't want to waste any of the parts, or you want to make any other material that is square from it, but you don't want to waste any of the material. You just have to find the area of your canvas, then, or you find the H.C.F of your canvas. Then after finding the H.C.F of the length and the width of your canvas, you just, whatever you get at the H.C.F, it means that that is going to be the side, the length of side for your doormat. So for example, we have a canvas of dimension 16 meters by 20 meters. It means that the length is 20 meters and the width is 16 meters. Then the dimension of your doormat will be the highest number which can divide 16 and 20. So that will be H.C.F of 16 and 20. And when you calculate it, you get 4. That means the dimension or the length of your doormat should be 4 meters. Should be 4 meters. Then it means that the area or the number of doormats you are going to get, the number of doormats you are going to get from this size of canvas is going to be 16 times 20 divided by 4 times 4. For the area, this one for the area, the total area of your canvas, and then this one being the area of each of your doormats. And that is going to be 320 over 16, which will give us 20 doormats. So that means that if you have any, it can be any other dimension for your canvas, and then you want to find how many of it can go, how many square doormats you can get from it. You just have to find the H.C.F of the dimensions, the length and the breadth of your canvas. Then when you find the H.C.F, that means that that is going to be the size of your doormat. So you just have to calculate the area of your canvas and the area of your doormat. Then you divide the area of the canvas by the area of the doormat to see how many doormats you can get from it without wasting any material at all. So this is where we end the lesson on L.C.M and H.C.F. I hope it has been helpful. Fine, let me give you one assignment or two. Let me give you two assignments to try on your own before we call it a day. Fine. the I, L.C.M, and then H.C.F of the following numbers. So the numbers are A, 18, 24, and 42. B, 28, 42, 56. Yeah, you can find your own set of numbers and then you add up just to check and see whether you are doing well. All right. So I want to thank you so much for spending time with me in my study room today. Please subscribe if you haven't done that yet so that you can get regular notification whenever I post a new video. And I thank you so much for watching. Bye-bye.